All right, question 3A. Honestly, just a little bit more of the same. I'm going to keep going. You need a lot of practice with this. Except now the factoring is going to be just a tad more difficult, okay? Because you're going to see, even at, like the first two questions here, leading coefficients that aren't equivalent to 1. So we've got a 2 here, a 2 over here. Now, again, I am going to move a little bit more quickly through the factoring because the issue here is really not factoring. It's about how I deal with rationals. But just follow along here. So I've got trinomials in the numerator denominator, so I already have a sense that I'm going to be able to break those into binomial factors. The first one has got a leading coefficient of 1, so I already know it's going to be t and t. Here now I'm looking for two numbers whose product is 4 and whose sum is 4, and that's typically a pretty easy one. It's got to be positive 2 and then positive 2. Okay, so that's not the hard one. The denominator, though, has got a leading coefficient of 2. So now the first thing I want to do is see, is that common? And in this case it is. So I'm just going to quickly take a look at this. I can take out a 2 here and I'm left with t squared plus 5t plus 6. So now I'm factoring this. So I'm going to put that 2, and I really need to remember to put that 2 out front. Okay, what I'm trying to do is come up with another representation of this denominator here, and it had a 2 in it. So I have to include the 2 out front here. But now I'm just factoring the trinomial t squared plus 5t plus 6. Again, the leading coefficient is 1, so I know that the first two terms of those binomials will just be t's. Then I'm looking for numbers whose product is 6 and whose sum is 5. And again, we've seen this one already before in this package. That what makes sense here is this is going to be t plus 2, t plus 3. Okay? So, just like we've done a bunch of times before, I see that the t plus 2 divided by the t plus 2 will be 1, which leaves me with t plus 2 in the numerator over the 2, don't forget the 2, t plus 3 in the denominator. The original expression is equivalent to this one. They're not equal until I include the restriction that t cannot equal negative 2. Now they're equal. They've still got this implied restriction here that hasn't been stated outright, except I want you to. Okay, I want you to also include that t cannot equal negative 3. Now remember, this is what we have been calling the removable one. This is the essential discontinuity. Okay, those are the holes in the graphs. Those are the non-permissibles. So we're just getting into the habit of stating the non-permissibles related to the factors that I've removed that are equivalent to 1, and then the last ones that I include there are the ones that I'm left with at the end.